So we continue with 2024 mathematics paper 1. So that was GCE, and we are looking at this particular page. All right, so if you are new to this video or this channel, please hit the subscribe button. But we started answering questions from this paper, and we've answered quite a number of them. We are now on question 18. That's where we'll be starting from today. So the diagram shows a triangular prism ABCDEF, in which, so the key part here, we are told that there are lines that are equal here. Okay, we have several lines that are equal, AE, AD, and DE. So AE, AD, and DE are equal. So it's more like something like this. Okay, if you were to visualize it like that, then okay, so now these sides are equal. So this means that the sides are equal. It has an equilateral triangle. Okay, and if it has an equilateral triangle on top of it, this simply means that it has, so state the number of planes of symmetry. So it has 3 planes of symmetry. Okay, so 3 planes of symmetry for this one. Okay, you can cut it 3 times, like this side, that side. So both these diagonals 3 times. So this one, and then sure you can visualize this one. So it's 3 planes of symmetry here. Then we go to the next one. Okay, so in the answer space below is an incomplete written program for written pseudocode, sorry, for calculating the nth term. Okay, so when calculating the nth term Tn, the formula is given by we say Tn is equal to A plus N minus 1 then D. So this is the information that is even given here. Okay, so now that we have this, we can do this. Okay, so let's look at this part of the we have to fill. So this one, the first question, we said 3 planes of symmetry. Okay, so we say 3 planes. So start, this is the first thing, then enter. We're going to enter all these. Okay, and forgetting the constants, right? So we're going to say enter Tn A N D, and Tn is equal to, this is the formula there. Sorry, let me just write this nicely. Then D, output Tn, and this is all that you have to do in this question. Okay, that is all. So we go to the next question. So question 19, in the answer space below, draw AC, given that this and that. So we've been given this, we need to draw AC. Okay, so 3 to 1. Okay, so we have you're going to do this. So we have A A is equal to 1 3, and then B, so these are given in vector form. These are given in a vector form. Okay, my writing today is okay. So we do this. So let's go to B, that is okay, 3 1 and then 1 negative 3. So A is 3 1, then B is negative 1 and then 3. I think I've, sorry, not over. I think I've gotten this one correctly now. Okay, so here's what we have. So A, this is the coordinates for A. Okay, so the coordinates for A, this is 3, and then this has to be 1 because we take them like so, x over or xy. Okay, so B is actually, let's see, let me get this nicely. I'm not seeing these. Okay, so A, sorry, so we have AB, sorry, let me write them here. So AB is 3 1, so this is AB. Okay, this is AB, and BC, that is 1 negative 3. Okay, then draw AC. Okay, we draw AC. So let's go to the part where we have to draw. Okay, so AB, this is AB is actually 3 1. So we're going to say that AC will simply be equal to, AC will be equal to AB plus BC. So AB is 3 1 plus BC is 1 negative 3. So when we add this 3 plus 1, that will give us 4. 3 plus negative 1, that will give us same as 1 minus 3, that is negative 2. Okay, so this will be AC. Okay, this is going to be AC. Now for us to show AC, for us to show AC like this, we can say that so AB was 3 to 1 BC, so we found AC, and that is what we have to show here. So that is x comma y. Okay, that is x comma y, so that is 4 to negative what, 2. Now since we're not given, we need to find out. Okay, so first of all, B A to B, so B to C. Okay, so B to C. So what we can do here is to, since we have the point A, okay, we have the point A. Now let's see if we can get the coordinates for the point C. Okay, so to get the point C, to find C, what we can simply do is this. Okay, so these are the coordinates that we should get for SCI, and here we're going to say, okay, if AB is 1 to 3, so to find BC, okay, so BC has already been given here. So BC, on the x-axis, we are going to move 1, okay? So we're trying to find BC. So on the x-axis, we are just going to move 1. So because you have a 1 here, so you move to your right 1. It's positive 1, so you move to your right. So you're going to move to your right and you're at this point. So when you reach this point, you come down 3 times. Negative says come down 3 times. So 1, 2, 3. So this is actually where this will be BC. Okay. So now to show AC, this has located as C. So to show AC, we're just going to do this. And this will be AC, okay? But we have already calculated it will be 4, negative 2. And you can see here that from the x-axis, you go 1, from A, you go how many times? 1, 2, 3, 4, which is correct. And coming down, 1, it's 1, 2, which is correct. So this is how you're supposed to show this one. Let's go to the next question. The next question is saying the straight line that passes through that point, find the coordinates of the y-intercept. Okay, so the straight line y, let's answer this question. So the straight line y is equal to half x plus p. So it's passing through this point. So this is x and this is y. Find the coordinates of the y-intercept. Find the coordinates of the y-intercept. So we are going to replace these values in this equation. So y there is going to be 2, okay, is equal to half. Our x there is going to be negative 2. Then plus what? Plus p. So we're trying to find what p is, okay. So there 1, there negative, okay. So 2 will be equal to negative 1 plus what? Plus p. So when you move this side, this is going to be 2 plus 1 is equal to p. So in other words, p is equal to 3. Okay, so now that we have this, it says find the coordinates of the y-intercept. Okay, so the coordinates now for the y-intercept, now that we have p is equal to 3, right? So we're going to do this. So this half here is your gradient. So we're going to say the half there is our gradient. And this p is our constant, okay? This p is the constant. So for the y-intercept form, what we normally do is that since we are looking specified for the y-intercept form, so for this one we're going to say that x is equal to 0. Right? On the y-intercept, x is equal to 0. So if x is equal to 0, and they want us to find the y-intercept form, okay, so this is going to, we're just simply going to put a 0 here, and then we find the y value, okay. So y will be equal to, the gradient is still this, but x here is going to be 0 plus p is what? P is 3. So y is going to be this half times 0, that is 0 plus 3. So y will be equal to what? 3. So the coordinates now will be, we said on the y-intercept x is 0. So that will be 0, comma 3. And this is the answer, okay. So if you have something like this on the y-intercept, on the y, you always know that x is equal to what? Is 0. Right? So this is called x is equal to 0. All right, so from this, we can go to the next question. So here is a question. In the diagram, A, B, and C are 3 points on a level ground. The bearing of AB from A is 137. Here it is. The bearing of C from B is 250. There it is. The angle ACB is 35. Find the bearing of F from B. F from B, so from going to A, that's what we're interested in. This is how you find these bearings. So A from B, so where it says from, that's why you start from. So going to A is this one. So bearing of F from B will simply be, let me erase this, will be okay, will simply be all the way from B going to A, okay, like this. So this bearing here. So already from here, use a different color. Already from, if I use blue, okay, so already from here, just this part here, it is what? 250, we are told 250. So we just need to find this remaining part which is inside here. And then we add, that will give us our answer. Okay, now looking at this, there we can see how we can find, because this is a triangle. Now we just need to find this one here that I'm going to call x. Okay, so now for us to get that x, there are many ways that we can go about it, and one of the ways is maybe we can try to find the bearing here. We can call it y. This will be very easy to find because of this bearing that we are given here. So when you add this and this, according to the rule, okay, if you have a line like this, another line like that, the way these are, here is 137 and here, so these two should always add up to 180. So if we say that 137 plus the y that I've written here is equal to 180, this is the rule. This and this should be, so you can see the way this is arranged. Okay, these are corresponding angles, so they add up to 180. So to find for y, we can just take 137 this side, and this will give us y is equal to 180 minus 137. So we can easily find y, and we're going to see how that is important, or how we are going to use that actually. Okay, so 180, no calculators here. You say 180, okay, 180 minus 137, 180 minus 137, you get 43. So now if here it's 43 degrees, 43 degrees here. So what this tells us is that if you add 250 plus 43 degrees, the only thing remaining will be x. So if we say 250 plus 43, that will give us 9. So now remember, if this is a complete thing, we add everything now, it's supposed to give us 360. So 43 plus 250 plus x should give us 360. So to get x, you're just going to say 360 minus x minus 293. This will give us the remaining one, x, because we've added everything except for this one, and we know that if it's a complete circle, it will be 360. Okay, so let me say to you want to find x. Okay, okay, so we are just going to get 67 for this one. So that is we are not yet done. So we found x. So here is 67 now. Now remember what the question was saying. The question wanted us to find the bearing of f from b, meaning this whole bearing. So meaning the 250 plus the 67. So here it's going to be 250 plus 67. Okay, so 250 that will give us 317. Okay, so that is all for this one. Now we go to B. A from C, A from C. So A from C. So that is, we make a north at C. Okay, we're going to make a north at C. At C here, you come up with a north. We draw that nicely. So this is north. Let's see. So from C going to A, so they want us to find this angle that is here. So remember here we found what? 63. Sorry, 67. And here we found 43. So we are asked to find this bearing here. So the way we can do this, we can find for this one, adding this and this, then you subtract from 180. Remember, it's a triangle. Triangles add up to 180. So that will be 67 plus 35. Okay. So this and this will give us 102. So when we say 180 minus 102, okay, this will give us 78. So this means here it is 78. Okay, so now that we have 78 here, my job is to find this one, but I have to get this first. So when you add this and this plus this should give you 360. So this means 360, because it will make a complete circle, is equal to 137 plus 78. That one I've just said y. So this is going to be 137 plus 78. That is 215. So this is 360. So we take this one here. 360 minus 215 is equal to y. So this would be 145. Okay, so in other words, this is 145. So now remember, this and this, similar to what we had done, okay? When you have this like this one and this one add up to 180. So let's call this one x. So this and this should give us 180. So say that x will be equal to 180 minus 145. Okay. And you get 35 degrees. Hence, that's the bearing, right? It is 35 degrees. Okay, so other people write them in 3. So, like this, right? Which is the correct way of writing them. Okay. And that is what you want to do in this question. We go to the next question. Okay, so this is a question. Write the four inequalities that define the unshaded region. So we have quite a couple of questions. I was hoping I'd finish this one, the whole paper. Let's see how far we can. So write 4 inequalities that define the unshaded region R. Okay. So we start with this one. This one, you can see this line is passing on. This is the y-axis, right? So we call this one. This one is passing on 1. So we call it y is equal to what? To 1. But then we must use those inequality symbols. So you can see the line is bold, very bold line, and they shaded here. So you see that all the numbers down that were shaded are less than. Okay, these are less than 1. So we are going to say that the unshaded region here is y is greater than or equal to what? To 1, and that is our first inequality because we are describing this unshaded region. The shaded one, all these numbers are less than 1. What else can we take? We can get this one here. It's passing on 6, and it's cutting the x-axis. So we say x is equal to 6. But then you look at the line is dotted. It's not a bold line. And the numbers that are shaded are numbers that are beyond 6 or greater than 6. But the shaded region are numbers less than 6. So we're going to say x is less than 6. And we're not going to put a line here. This is because the line is not a bold line. Okay, the line is not a bold line. So this is our second inequality. This is our first inequality. Then we're remaining with 2, so we can get this one here. So for this particular one, you have points. This is 6. That is 6,0. And this point, it is actually 3. Sorry, it is 0,3. Okay, it is 0. Just do that nicely. 0,3. Okay, so 0,3. So we can make we say that y minus y1 is equal to the gradient x minus x1. So for the gradient, we can always find the gradient. Let me just do it here. y2 minus y1 over x2 minus x1. So y2 is actually, in this case, this is x1 and this is y1. This is x2 and this is y2. So y2 there is 0 minus y1 is 3. x2 is 6 minus x1 is 0. So negative 3 out of 6. And we reduce this, it's going to give us negative 1 out of 2. So this is your gradient. Okay, this is your gradient. So you're going to say y minus y1 is 3. Your gradient is negative 1 over 2. And x minus x1, that is 0. So y minus 3 is equal to negative half. Okay, x. This by this is 0, so I'm not going to write it. Then you can take your 3 this side. So y is equal to negative half x plus 3, since it crosses the equal sign. So this is the equation. Now we need to find out, look at where they shade. Okay, we're going to use 0, 0 as our test point. Okay, so to use 0, 0 as our test point, here we're going to say that since we're using 0, 0 as our test point, So we're going to replace the x and the y value with 0. So that will be 0 is equal to, if you put 0, 0 multiplies by this, so that will be 0 plus 3. So we have 0 is equal to 3. Then now which side now we're going to use? So you watch, okay? If we put 0 is greater than or equal to 3, or we say 0 is less than or equal to 3. So what this means is that we need to find, is this true? Is this true? No, this is not true. Is this true? Yes, yes, 0 is it. So now, if this is true, it means that 0 was shaded, So was 0 shaded here? Correct, 0 was shaded there. Okay, 0 was shaded. So this satisfies our problem. Something 0, 0 was shaded, Okay, 0, 0 was the shaded part. Okay, then we are describing the unshaded region, so we're going to go with this. So the correct symbol that we should put here is actually going to be y is greater than or equal to negative half x plus 3, and that is all. We have one more, which is this one here. Okay, so this one we know something about it. It's meeting 2 points here. This is 6,6, okay. So 6,6, that is 1 point, and also 0,0. So yeah, there we're going to do it. So 0,0 will be x1, y1. This one will be x2, y2. So your gradient y2 minus y1, x2 minus x1, y2 is 6, y1 is 0, and then x2 is 6, x1 is 0. So you get 6 out of 6 and you get 1. Okay, so then you go y minus y1 is equal to m x minus x1, and then so this is going to be y minus y1 is what now? 0. Gradient is 1, so this is going to be x minus x1 is 0. So this is going to be y is equal to 1 times x, that is x, 1 times 0 is 0, no need to write it. So this is y. So this is the graph y is equal to x. Now to find the sign now, this is a dotted line, so you can either put this sign or this sign. So if we put y is less than x, we can say y is greater than x. So look at the shaded part, okay? Look at the shaded part. And once we look at the shaded part, we can get a point. Either let's get this point here, which is 0,6. So 0,6, this is going to mean 6 is greater than 0, 6 like that, okay, because the x-axis here is 0. Okay, so this is the test point that we're using, So this is x and this is y, that's why I've put it like this. So 6 is less than 0, this is not true. 6 is greater than 0, this is true. So now if this is true, 6 is good, it means that this part was shaded. Was it shaded? Yes. Okay, this part was shaded. It includes the shaded region, includes this part. Okay, so to describe the shaded region, we're going to use this other one. So it's more like you're just doing the opposite. So y is less than x, and this is the final equation. Okay, go to the next part. The graph below shows a sketch of that passing through those points. Find the coordinates of a and of b. The mini turning point, solve that equation. Okay, so the remaining questions 22, 23, we're going to solve them in our next video. So watch out to the next video, those who have been far away. In the next video I'll be solving question 22 and 23.